This is a program to transfer string message from one location to another. In the string message in 8086, to move the message from source location to destination location, the source operand must be in it must be in the data segment, and destination operand must be in extra segment. So we can observe here VCT is the character of the array of characters stored in the data segment. So string means it is array of characters. Data segment, it holds the data required for the program, and in the program we can see data is the name given to the data segment, and extra is the name given to the extra segment, and code is the name given to the code segment. So extra segment holds the destination operand, and code segment holds the instruction required for the program. In the data segment we can observe data segment and extra segment ORG used to represent, or it will initiate the starting address of the memory location. So I have taken ORG 8500H is the starting address of the data segment where VCT is stored, and ORG 9500 is the starting address of the memory location named location 2, where we have to move the VCT message from data segment to the extra segment, and location 1 and location 2 are the name given to the memory locations. And ends, data ends and extra ends are the assembler directive that will terminate the logical segments, data segment and extra segment. And assume is the assembler directive that used to represent, or we can initialize the starting address of the code segment to the code segment register CS, then data segment to the data segment register DS, and extra segment to the extra segment register ES. And in the code segment, the first 4 instruction we can observe move AX, data, move DS, AX used to initialize or move the starting address of the data segment to the data segment register through AX register, and move AX, extra and move ES, AX are the 2 instructions required to load the starting address of the extra segment to the extra segment register. And we can observe LEA SI, location 1 and LEA DI, location 2 are the 2 instructions required to load the offset address of the location 1 to the SI register and location 2 to the DI register. As I told in the string instruction, we have to use SI for the data segment and DI as an index register for extra segment. LEA represent load effective address. After execution of LEA SI, location 1, SI will get the value of 8500H, that is the starting address of the location 1, and after execution of the location LEA DI, location 2, DI will loaded with the 9500H is the starting address of the location 2. Then next instruction move CX, 04H is the number of how many number of data we have stored in the memory location. That count value should be loaded to the counter register. So VCT 4 characters stored, that will be loaded to CX register. Next CLD. CLD we can use this instruction in the string instruction string program. So because CLD that will clears the direction flag. Direction flag is the one of the flag bits in the PSW in 8086. If you make it to 0, DF is equal to 0, automatically SI and DI register will get incremented. So no need to write INC SID, INC DI. We can use CLD directly. Next instruction repeat. We can use either repeat or loop instruction. Loop means the body of the loop repeats until CX is equal to 0, or we can say loop instruction will decrement the CX and jump if non-zero up. That will repeat the body of the loop. Instead of writing loop in the string, we can write repeat instruction, REP. So repeat means it's similar to the loop. It will repeat the move SB instruction until CX is equal to 0. Move SB is the instruction. It's a special instruction used only in the string program that will move string byte. So it will move the content from the source operand or data segment to the destination location extra segment. So repeat. So we can reduce the instruction in string program by writing CLD instead of writing INCSI and INCDI, and instead of writing loop instruction we can write REP, and move SB directly it will move the content from string one source to the destination location. Then last two instruction, move h, 4ch and int 21h are the two instruction required to terminate the program, or it is a interrupt program to terminate the 8086 program. Then the last two instructions, ends and end, are the assembler directive. Ends, it will end the logical segment, and end is the assembler directive used to end the whole program. So next we will execute this program by typing the command massum data2 is the name given to the file name, data2 dot asm semicolon. So it will give the whatever the error present in the program. In this program 0 errors. Next go to the next this one command, how to link the objectable files. So link data2 dot obj. So objectable file will be linked to the library by using this instruction or this command. Next we have to execute the executable file by using debug instruction. af debug data2.exe. So we'll be getting the output screen now. Here we can observe data code segment, data segment, and one more part of the data segment we have to use it as a extra segment for loading the content from data segment to the extra segment. So we can observe here a different AX, BX, CX, DX are the general purpose register, SIDA are the index register, BPSP are the pointer registers, CS, DS, ES, SS are the segment registers, hold the starting address of the code segment, data segment, extra segment and stack segment. IP is the instruction pointer used to hold the offset address of the code segment. This part it is a code segment holds the instruction, and this is a data segment holds the source operand, and this is the extra segment holds the destination operand. And PSW we can observe here flag register content, OF overflow flag, direction flag, interrupt flag, sign flag, zero flag, auxiliary flag, parity flag, carry flag. These are the different flag bits in the flag register. So we will check one by one. The starting address of the data segment loaded to DS, then starting address of the extra segment loaded to ES, then here SI will get 5643 and 4554 are the ASCII value stored in the memory location for VCET array of characters. Now after moving next it will load the effective address 9500 to DI. Now CX is loaded to 04. Now CLD it will clear the direction flag. Now repeat move SP. So after execution of this single instruction, 56 will be moved to 9500 location. We can observe here. So how many times it will repeat until CX is equal to 0. Now we can see CX has become 0 and all the value 56, 43, 45, 54 has moved to extra segment. So this is these four values are the ASCII value for the corresponding VCET characters. So this is the program for transferring the string from one location to another. Thank you.